Now our next polymer is thiokol. Its monomers are 1,2-dichloroethane or ethylene dichloride and sodium tetrasulfide. So we can also use magnesium hydroxide in this reaction. Now this is basically known as polysulfide rubber, and it is exceptionally resistant to oxygen, ozone, mineral oils and solvents. Moving on to our next polymer. Our next polymer is nylon 66. Its monomers are adipic acid and hexamethylene diamine. Nylon 66 is very important for exams point of view. Its monomers are adipic acid and hexamethylene diamine. Now there can be a question that what does 66 in the polymer means. Now 66 represents the number of the carbon atoms in the monomers. So it is an example of polyamide. Now we very well know that peptide bond or amide bond is formed when a carboxylic acid reacts with a amine group, or a carboxylic group reacts with the amine group. This CONH linkage is known as a peptide or amide linkage. It is an example of a condensation polymer. The temperature is around 525 Kelvin. We use water in the form of steam and nylon in molten state. Our next polymer is nylon 6. Its monomer is caprolactam. Now caprolactam is very interesting compound. It is basically a 7-membered ring compound. The monomer has 7-membered ring. Nylon 6 is also known as Perlon, and it is also an example of polyamide. So which of the following is a polyamide? Nylon 6 will be our answer. Now let's try to prepare the polymer from cyclohexane. Cyclohexane, when it is treated with oxygen, it forms cyclohexanone. In the presence of NH2OH, it forms cyclohexanone oxime. In the presence of concentrated H2SO4, this molecule shows Bachmann rearrangement to form caprolactam, and at a temperature of 533 to 543 Kelvin, it forms 6-amino hexanoic acid. So we get hexanoic acid, amino hexanoic acid from caprolactam, which is, if further heated, forms our nylon 6 with the release of H2O molecule. So that is about the polymerization of caprolactam to form nylon 6. Now moving on to our next polymer. Our next polymer is nylon 610. Now its monomers are hexamethylene diamine that contains 6 carbon atoms and subacic acid that contains 10 carbon atoms. So the 6 and the 10 number represents the number of carbon atoms in the polymer. So it is example of polyamide, and it is a condensation polymer. Now our next polymer is Kevlar. Its monomers are terephthalic acid and 1,4-diamino benzene. Again, it is basically a polyamide. It is also known as a aromatic polyamide or aramides. Now Kevlar is very important. Its uses are, it can be used in bulletproof vest, army helmets, and it is basically stable at a high temperature. So it is used as a protective clothing worn by firefighters. So the chains are basically held together by hydrogen bonds that cause to form sheet-like structure. So that is all about Kevlar. Moving on to our next polymer is Bakelite. This is very important for exams point of view. Bakelite contain phenol and formaldehyde as monomers. Now what is interesting to note here is it is also known as a phenol formaldehyde, or it is an example of a thermosetting polymer. Now if it is a cross-linked polymer, then it is known as Bakelite, but if it is linear polymer, then it is known as Novolac, that is basically used in paints. So the reaction occurs in the presence of a base or an acid. First, phenol reacts with formaldehyde to form orthohydroxymethylphenol and parahydroxymethylphenol. So sometimes sulfonated bakelites, they are used as an ion exchange resins. So when our ortho product is polymerized, it forms Novolac, that is a linear polymer. The Novolac and formaldehyde, when they are heated, they form Bakelite, that is basically a cross-linked polymer. Now our next polymer is Epoxy Resins. Moving on to our next polymer, its monomers are bisphenol and epichlorohydrin. Now first, there will be a release of HCl molecule to form a pre-polymer. Then in the presence of a hardener, it forms cross-linked epoxy resin. Now these are basically strongest adhesives known. Our next polymer is melamine formaldehyde resin. Its monomers are melamine, which is basically 2,4,6 triamino 1,3,5 triazine, and formaldehyde. So this is the polymer representation of melamine formaldehyde. Please remember, this is also known as Malmac. Melamine formaldehyde resin is important as it is used in non-breakable crockery. It is an example of a thermosetting polymer, and it is colorless. Our next polymer is polyurethane. Now its monomers are toluene 2,6-diisocyanate and ethylene glycol. Now when isocyanate that reacts with alcohol, it forms urethane. Now it is basically a step growth polymer, but a small molecule is not lost during this polymerization. It is basically used in fabrics with elastic properties, for example lycra. It is soft. It is amorphous segments that becomes crystalline on stretching. Now these are the polymers for today's video. In the next video we will study about biodegradable polymers. Few examples of biodegradable polymers in the next video.